One.
Hi everyone, I am Pooja Har from N section Cloud Computing. Next, my topic name is Operating System FCFS Scheduling Design and Evaluate. Next, Introduction. CPU scheduling determines the order in which process are executed by the processor. First come, first served. It's the simplest scheduling algorithm where the process that arrives first is executed first. This assignment design a complete FCFS simulator, evaluates it using different datasets and justifies whether FCFS is suitable for real-time system. Next. Experimental setup. Hardware used processor Intel AMD, any standard, RAM 4 GB or higher, operating system Windows or Linux, and software used Python 3.8 plus or in Java, code editor, VS Code or an Eclipse, input required, dynamic arrival time, burst time for each process, output generated, waiting time, turnaround time, completion time, and Gantt chart. Next. Implementation steps. Input process details, accept number of processor, entire arrival and burst times, sort processes by arrival time. FCFS scheduling requires processes to be arranged in increasing order of arrival time. Simulate CPU execution. It CPU is idle. Time jumps to the next arrival. Each process runs to completion non-primitive. Calculate matrix waiting time, sort time, arrival time, turnaround time, completion time, arrival time, sort all results, include PID, arrival time, burst time, waiting time, turnaround time, completion time. Repeat for three different datasets, vary the arrival and burst times to compare the performance. Next. Code. The program is in package FCFS and simulates FCFS first come first serve scheduling, and it imports Java utilities like list, array list, and comparator and scanners. And the static inner class process stores process details, ID, arrival, burst, start, completion, turnaround, and waiting. Next. Next page. Here the constructor initializes PID, arrival, and bus values to string formats process into for easy tabular printing. The method run FCFS executes scheduling on the list of processes or sorted by the arrival times table sort preserves input order for ties. Next. The variable time tracks CPU clock, total track waiting and turnaround averages for each process. If CPU is idle before arrival, an idle block is printed and start time is set to the current time. Completion time is equals to start plus burst. Turnaround time is equals to completion minus arrival. Waiting time is equals to start minus arrival. Next page. Here CPU time advances to process completion. Gantt-like timeline is printed showing execution intervals. After all the process details are printed in a table: PID, arrival, burst, start, completion, waiting. Next page. After all process details are printed in a table: PID, arrivals, burst, start, completion, waiting. Average waiting and turnaround time are computed and displayed. Three sample datasets A, B, C are provided for the quick testing. In main, user closes the manual input or sample datasets. Manual mode asks for process count, IDs, arrival, burst time, then runs FCFS. Next. The output of this code, FCFS scheduling simulator, enter process manually, run sample dataset ABC. In that we are choosing a first one, how many processes we are taken to across first ID. Example, we will give it as an processor 1, it has an 1. Arrival time for the processor 1 is 2. Burst time for the processor 1 is 4. Processor 2, we are giving that 5. The arrival time for that 5 is 3 and burst time for that 5 is 7. Gantt like execution start to and completion. Process details. Here the process ID is 1 and an arrival rate here 2. Burst rate it will become 4 and ST2 CT6 and then waiting time it will become a 0. For an 5 processor ID we are given a value as 5 and ARR will get a value of 3. Burst time 7. Start time we will get 6 and completion time 13 and then waiting time 3. Average waiting time will be 1.500. Average turnaround time will be 7.3 7.000. Next, this is the code. This is the output of this code. Next, observation dataset 1 processor ID arrival. For a processor 1, we are given a arrival time is 0, burst time 4, waiting time 0, turnaround time 4. Processor 2, arrival time 1, burst 3, waiting 3, and then turnaround 6. For processor 3, arrival 2, burst time will become 5, waiting 6, and then turnaround 11. Average time waiting will be 3.33 milliseconds. Average turnaround time will be 7.33 milliseconds. It is same as like a data set one, but the values are different. Next, comparative evolution. Data set is 1. Average waiting time will become a 3.33 milliseconds. For data set second, 8.75 milliseconds. Average turnaround time 7.33 millisecond. We observe that balance load, moderate and performance. For 13.25 milliseconds convey effect due to a long burst time. Widely depending on process arrival patterns. Next, the conclusion. The FCFS scheduling algorithm is simple and easy to implement, but it shows inconsistent performance across different datasets. It performs well when arrival times are spread out, but performance poorly when a long process proceeds short ones. Due to its non-primitive nature, FCFS cannot guarantee deadlines, making it unsuitable for real-time systems. Algorithms like round robin, SJF, EDF, or an rate monotonic or better for time critical applications. Thank you.